So for next section of chapter 2, we're going to be looking at ways to display the quantitative data. So quantitative variables, again, just to remind you, these are variables that can be measured as opposed to categorical, where you fit into categories. So for instance, height, age, weight, distance, time, things like that. So the first way we'll talk about how to display quantitative data is with what's called a histogram. So this is just a chart that displays quantitative data. And so you can see from this one is a histogram showing the ages of the passengers on the Titanic. And notice a couple of things about this. So we have ranges of data. So you don't have just the 10-year-old and 11-year-old and 12 and so on. We group these points together over certain age ranges, and we'll talk about how you might want to do that in a minute. But for instance, this bin is from 10 to 15, 15 to 20, 20 to 25, and so on. And like the bar chart that we looked at in the last video, the widths are all going to be the same, and in this case, they're all going to have the same range, like the same range of data. So in this case, 5 per bin. You would not have 20 to 25 and then have 25 to 35 or 30 to 50 or something like that. So all the bins will be the same width, and then the height will determine how frequently those ranges of data occur. And the other thing to notice that's different from the bar chart, other than most of the time on a bar chart, you'll have words down here, because usually categories have words. Although it is possible to have categorical data that's labeled with numbers. For instance, a zip code would be a categorical variable, but it has numbers. So not always true that bar charts have words, but most of the time that is true. So if you see numbers down here, typically it does mean quantitative data. But the for sure way to tell is bar charts always have a gap between each bin. In a histogram, you don't have gaps. A gap would mean that there is no data in that bin. So if there's a gap here, there'd be no one between 45 and 50 on the Titanic. So most of the time there are no gaps, and especially not between every single bin. So here's some of the benefits. Great for seeing the distribution. You can see if it's symmetric skewed, and we're going to talk about some of those maybe in the next video. The most populous group was 20 to 24. That's going to be the tallest one. And I guess, so 20 to 24, I guess they're not counting, parts of ages or whatever. But 20 to 24. Youngest were infants, oldest, so we have all the way down to 0. We have all the way up to few that are above 70. And then as we get past 25, you can see that this histogram is going to keep decreasing and decreasing that way, which normally happens. Normally, most of your data will be in the center, and then it kind of tails off. It gets lower as we go to the edges. So that's pretty typical. Now, choosing the width. So like I said, you want each bin to be the same width. So here we have these two histograms are showing the same data, earthquake data in this case. And in this one, 7 to 7.5, 7.5 data, and so on. But over here, we have, it looks like 5 bins between 6 and 7. So that means it'd be 6 to 6.2, 6.2 to 6.4, and so on. And you can see a little bit other details on this one compared to this one. So just all depends on what you want to show. So choosing, or let's say different bin widths show different features. And obviously it's the same data, but you can see a little bit more detail on this one, but there is a fine line between um, too much detail versus not enough. Like obviously you probably don't want to go 4 to 6 and then 6 to 8 and then 8 to 10. Like that's probably going to be too wide. But if you get much more narrower than this, that's probably going to be too much detail and not as helpful. So you got to find the kind of happy middle ground there. So we want to choose the width. That best shows the important features. And we're going to talk about those as we go along. What are the things that you want to look at when you're looking at a histogram? And then, like I said a minute ago, a gap means no data in that range. And typically you have gaps, or if you have gaps, like it looks like there's probably a gap right there. So there's just no data from 4.6 to 4.8. All right, so the next one that we're going to look at is called the stem and leaf. So the stem and leaf is kind of like a histogram, and if you could turn this on its side like that, it would look a lot like a histogram. So the stem and leaf shows both the shape of the distribution, and individual data points. So for this one, pulse rates per minute, beats per minute. Normally, and pretty much you have to have this, you have a little key here to explain how you read this. But each of these are all data points. So for instance, 5/6 means 56, like it says there. Now, each of these are individual data points. So 60, 64, 64, 64. And then as we go down, 4 data points are 72. So each one on the right side represents 1 data point. And then this will just be the leftmost digit, in this case, the tens digit. But I mean, it could be 5.6 or 0.56. And that's why you need the key right there to explain that. So the drawback for this, for stem and leaf, is we can only use these for smaller data sets. Obviously, if you have hundreds of data points, you don't want to individually put them all on here. And then, so that brings us to dot plots. And a dot plot is similar to a stem and leaf, except instead of stating the individual data points, we use dots to represent the data points. So use dots to represent data points. And maybe instead, if you were going to use this one, instead of the stem and leaf, it might be where you don't have a wider range, maybe, or you have a whole bunch of data points that have a single value. So for instance, 30, so these are number of races and the winning time. So in this case, 30 races had a winning time of 122 seconds. So if you look right here, 122, that one comes all the way out here, and where it says 30. So looks like it could be 29, but that's okay. But you get the idea. So that's what those are used for. Now, think before you draw. Just like with the categorical variables, before you draw, you need to ask, is the variable quantitative? So in this case, we're looking at quantitative variables. And I guess generally speaking, if you're just going to ask that question, you ask what type of variable are we talking about, quantitative or categorical? So from the last video, bar charts, pie charts, and frequency tables are for categorical variables, and histograms, stem and leaf, and dot plots are for quantitative. So it's very important to keep those straight. When do you use which one? Obviously, you cannot use a pie chart to plot quantitative data. You cannot use a histogram to plot categorical data, so on and so on. So make sure you know how to use these, know how to read these. We're going to talk more about it in the next video. A lot of things you can talk about with histograms. So we will pick it back up then.